So we are talking about random variable, okay? This is chapter 6. When I talk about random variable, do you know what is a random variable?
Random variable is no.
Random variable would be any variable. We take a random variable as capital X, and this capital X, why we say it is a random variable? Because it can take any values. It can take any values, and what value it will take, that I do not know now. And we are trying to find the probability of this random variable X. The reason why I say this is random variable, because it is random. I am trying to find the probability of this random variable X, and this X can take any values. What value will this X take? We will come to know after the event happens. Okay, so we say this is the probability of a random variable X, which can take any values of small x, and this small x we come to know after event happens. Are you with me?
Yes, miss.
Can you tell me, give me some examples of random variable taking any values and the value we come to know after the event happens?
The total of a dice.
Okay, the total of the dice, no problem. Can I say I am trying to find the probability of people running in a 1 hour race? Okay, running in a
Okay.
marathon. Okay, the time taken to complete the race. And what time is taken to complete the race, I will come to know the different small values of x only after the race is completed,
Yeah.
or maybe the time taken to complete a puzzle. So I
Okay.
say capital X is the random variable whose probability I'm trying to find. And this x can take any values of small x, and this small x I come to know only after the event is completed. So that is why in discrete random variable we find the probability of capital X is equal to small x. I hope you're with me.
Yes.
So x is a random variable, and this random variable can be a discrete random variable, or it can be a continuous random variable. What is the difference between a discrete and a continuous variable?
Discrete is when it's contained to a certain value,
Hmm?
and continuous is could be
It is
anything.
within a range.
Yeah,
So
within a
discrete
range.
will take a certain value and continuous will be within the range. So
Yeah.
understand this chapter, the capital X and the small x are really very different. Capital X will be your random variable, and small x is the value which your capital X can take, which we will come to know after the event is happening. Okay, so
Yeah.
capital the random variable is denoted by an uppercase. Are you with me?
Yes.
And we are trying to find out the probability of capital X is equal to small x. Let's take it with one example. This is my discrete probability distribution. A probability distribution would have the values of x. What is the small x?
It's the value that you could get, the outcome.
The values that this random variable x can take. Mahat,
Yeah.
please answer. So this small x is the values that this capital X can take, and when I'm talking about probability, I would find the probability of this small x.
Yes.
And when
No,
I
sorry.
we are finding the
The
probability of
probability is gonna
small
be
x.
the outcome.
Yeah, yeah, probability will be the possibility of this small x happening.
Yeah.
Okay, and this random variable x could take any values of this small x. So
Yeah.
here I am throwing 10, 10 cards. Okay. When I s- throw these 10 cards, the values that I could get on my card is 1, 2, 3, and 4. Are you with me?
Yeah.
Yes.
So, can you tell me the values that X can take?
The 1, 2, 3, 4.
1, 2, 3, 4. When I'm finding the probability, so how do I find it? Probability of having 1, probability of having 2, probability of having 3, and probability of having 4. Am I correct?
Yeah.
Can you tell me the probability of getting 1?
2/10.
1 is coming 2 times, so it would be 2 by 10. Probability of getting 2,
3/10.
of 3,
3/10.
and of 4 would be 2 by 10.
2/10.
Okay, so understand, I'm finding the probability of 1. It's this probability of a discrete random variable x when x takes the value 2. X becomes 3, x becomes 4. Understanding this is very important, and this table is called what?
Probability distribution table.
Probability distribution table. For any of this distribution, when I sum up, when I sum up the probability of my random variable x with all the values of its taking, with all the values of x that it is going to take, it will always be equal to 1, which means that 2 by 10 plus 3 by 10 plus 3 by 10 plus 2 by 10 is equal to 1. I hope you're with me.
Yes.
Okay. How do you remember anything about probability mass function?
No,
Probability
miss.
mass function? No.
Okay. Yeah, Maha, you remember you said, right?
Miss, I said no.
Okay, this is a probability distribution table. X is my random variable. This random variable can take any values of the small x, and this small x I come to know after the event happens. Right? When I put this x, this is the values that x can take, and I'm finding the probability of small x and I put it over here. Okay, and we will always write x is equal to x. This is called the probability distribution table. When I write it in the form of a probability mass function, the first thing I will write is probability of capital X equal to X. I put an equal to sign, curly bracket, probabilities, values X can take. Curly bracket, probabilities, and the values X can take. I'm repeating again. Curly bracket. Can you all repeat it, please?
Curly bracket, the values x can take, and then the probability.
Curly bracket, probability, values X can take. It is CPV. Curly bracket, probability, values X can take. Okay, so I have the curly bracket. Can you give me the probabilities that I have?
1, 2, 3, 4. I mean, it's the other way around.
We have the probabilities of 0. You know the probabilities, right? What was it?
That's 0.4. Yeah, yeah.
Okay. So probabilities that I can get is I can either get 0.2, I can get 0.3. I hope you're with me. When will I get 0.2 when x is equal to 1 and 4? When will I get 0.3 when x is equal to 2 and 3? So this is the values that x can take. I hope you're with me. Curly bracket probability values x can take. Can you tell me the meaning of this? Can I have the meaning of this?
This is the probability that you get one.
Probability of x is equal to 1.
Yeah.
This,
Probability of x is equal to 2.
This,
Probability of x is equal to 3.
I refine it probability of the random variable x when x is equal to 4. I hope you're with me. Okay. So
Yes.
if they ask me to find the probability of x is less than or equal to 3, what will I add?
If x is equal to
Less than or equal to 3. Giving you a minute's
Then
time, try to write.
0.3
less than or
plus
equal to 3, which would be
0.1 plus
0.3 plus
0.15.
0.1 plus 0.15.
Probability that x is between 2 and 5. It is equal to 2 also and equal to 5 also.
So 0.1 plus 0.15 plus 0.25 plus 0.1.
It's less than 3. I'm waiting for answer.
0.3 plus 0.1.
Okay, there is another way to represent this.
Yeah, could be.
What?
Yeah,
What would it be?
I don't remember the other way.
Probability would be x is less than or equal to 2. I'm giving you time. Please do for this. Give me the answer for this.
X is less than 0. X is less than or equal to 0.6. So we're gonna add up everything.
How did you get 0.6?
Sorry, less than 6.
Less than or equal to 6.
Yeah,
If it's less than or equal to 6, then it means you're adding everything.
yep.
So it will be 1. How about this?
For this, they have a range of probability of x less than 3 and less than equal to 5.
Hmm.
So we're not gonna take 3 because it does not say equal to. So we're gonna take 4
X is
and
between
5's
3
probability.
and 5, right?
Between 3 and 5.
Yeah. So this is going to be there. This is going to be there, and 3 is not going to be there.
Yes.
Correct?
Yes.
Now, how about this?
Probability of x greater than equal to 4. So it's gonna be 4, 5, and 6.
Okay, now give me another way to write this.
Another way of writing this, probability of x, sorry, no, probability of 4 less than equal to
Can I
x.
write like this?
Yeah.
Yeah, can I write it like this? 1
Yeah.
is probability of x less than 4. What is
Yeah,
the
yeah, you could write
probability
it
of
like
x
this.
less than 4? Please use your calculators fast. 0.3 plus 0.1 plus 0.15. So it is 0.55. When I minus 1, I'm going to get 0.45.
Yeah.
Hope you're with me. I'm repeating this again. It's important. If it is probability of x greater than or equal to 4, the other way to write this would be what?
1 minus probability of x greater than equal to 4. Sorry, yeah, 4.
X is greater than or equal to 4. What will you write? I'm
X
recording.
is
Probability
less
of
than
x
4.
less than equal to 4.
How can it be less than or equal to 4?
Less less than 4, less than 4.
And if I want to write it in the form of less than or equal to,
So it's gonna be less than equal to 3.
1 minus probability of x less than or equal to 3. This concept will be helpful in normal distribution also. How you're going to answer is going to affect when you're going to use this video for revision. Okay. So I hope this concept is clear. If you want to convert anything from greater than or equal to less than or equal to, this concept is very important in normal distribution. If I have probability of x greater than or equal to 4, I convert it into less than, it would be 1 minus probability of x less than 4, or it could be probability of x less than or equal to 3. Let's do over here. What is this box called?
Distribution table.
Discrete distribution,
Probability
probability distribution
distribution
table.
table for discrete variable. Okay. If all my outcomes is going to remain the same, then it is called a discrete uniform distribution. If my outcome is going to be the same after the middle value. That means if I go one left or one right, the probability remains the same. I go two left and two right, the probability remains the same. Okay, so such a type of distribution is called the symmetrical distribution. Okay, in a symmetrical distribution, the probability is identical each side the middle. So this side and this side identical when you go one place left and one place right. Plus, please remember the distance should be the same. Okay. Now, if I'm going from 7 to 5, what is the distance?
2,
If I'm going 7 to 9, what is the distance?
2.
2. So, probability is identical
Which means
each
it's symmetrically
side the middle.
distributed.
These words are important. Probability is identical each side the middle. It means it is a symmetrical distribution. So we learnt about probability distribution table, probability mass function. A distribution table for a discrete random variable can be of two types, actually three types. What are the two types? Uniform, symmetric. Uniform and symmetric. In uniform distribution, the probability of each outcome is the same. In a symmetric distribution, the probability is identical each side the middle. I'm finding about cumulative probability distribution. Listen to me. We are finding the
Hmm.
probability of random variable x when x can take the value of 0, 1, 2, 3, 4, 5, 6. Are you with me? Are you with me?
Yeah.
Here is x is equal to x. This is very important. Probability of random variable x when x can take the value of 0, when x can take the value of 1, when x can take the value of 2. But when I write probability of random variable x, when x is less than or equal to, it is actually f of x. Now, what is f of x? I am telling you. X is less than or equal to the small x. Okay? X is less than or equal to 0. Can you tell me what is the probability that your x is less than or equal to 0?
0.02.
Okay. What is the probability that x is less than or equal to 1?
0.02 again.
Less than or equal to 1.
0.02 plus
0.04.
0.34.
Yeah. So
What is the,
0.36.
okay, that means I added these two. Yeah, for
Yeah.
this, what is the probability that x is less than or equal to 2?
0.57.
How did you find that?
We add 0.02 plus 0.34 plus 0.21.
Very good. So this is x is less than or equal to 2. What will this be?
X is less than equal to 3.
This,
X is less than equal to 4.
this,
X is less than equal to 5.
and this.
X is less than equal to 6.
Very good. See, when x is equal to x, I just find the probability of x equal to 0, x equal to 1, x equal to 2. But when it is x is less than or equal to x, probability of the random variable x, when the random variable is less than or equal to, I'm actually finding the cumulative probability. So when it is this, it is actually f of x. So f of x is represented as probability of random variable x less than or equal to x. So this is f of 0. When I know when they tell you f of 0, the first thing that should come into your mind is what?
What?
When they tell you f of 0, what will come into your mind? What does this represent?
The
This
first value.
represents the first value, cumulative frequency.
But what? It represents probability of x less than or
Less than equal to 0.
0. If I say f of 4, what does this represent?
Probability of X less than equal to 4.
Probability of x less than or equal to 4. Remember that f of 4 is equal to probability of x less than or equal to 4, but it is not equal to probability of x equal to 4. Can you tell me why is this both not equal?
Because probability of X less than equal to 4 is the cumulative frequency up until 4.
Up
Okay?
until 4. Okay.
And X equals to 4 is just the frequency of X equals to 4.
It's just the probability of is just the probability that my x is going to take the value of 4.
Yeah.
Is the only thing to remember over here. Now another thing to write, how to write it. Remember, this is always in the form of x is less than or equal to. So if you have something greater than or equal to, you will convert it into less than or equal to. Can you give me, looking over here, probability of x less than or equal to 4?
Less than equal to 4 is 0.75.
Less than 4?
Less than 4 is 0.67.
Okay. Less than 4 is also equal to what?
Less than 4 is also equal to probability of X less than equal to 3.
Mahat, please answer this. X greater than or equal to 4. How would you write it? I'll pause the video. Actually, I want you to write both of this. Greater than or equal to 4 would be 1 minus x less than or equal to 3. I hope you know this concept by now. Now, please explain me this one.
Okay. So they want the range from 2 to 4.
Hmm.
And since it's 2 less than equal to X, so we're gonna take the value of
You
probability
will
of
first
X.
divide the data into two parts. You know that x is between 2 and 4.
Yeah.
Because here it's a small range, I can take this. Okay. Suppose you did
Yeah.
not have this, you only have this. So first you have to divide the data and make everything in less than or equal to form. How would you make it?
So I'm gonna write probability of X less than equal to 4
Hmm.
minus
This
probability of
has to be
X.
converted.
What?
This part has to be converted, right?
Yeah.
Hmm. Minus.
Minus probability of X less than equal to 1.
Okay. Both of you give me answer.
Miss, could you please explain the second one?
Can you give me answer for this, Harris?
Less than equal. Okay. So it's gonna be probability of probability of X less than equal to 2.
Huh?
No, no, no. Probability of X less than equal to 8 minus probability of X less than equal to 2.
Okay. Mahad, you need to see over here very clearly. Your x is between 2 and 4. Inclusive 2, inclusive 4. So if you do it
Hmm.
like that, it is going to be this, this, and this. 0.21,
Yeah.
0.1, and 0.08, which comes up to 0.39. Okay, but it is not necessary that always you're going to have this. Maybe you will have this part. So this part represents x is less than or equal to 0, x is less than or equal to 1, less than or equal to 2. We've done the meanings of this. Now this equation has to be written in the form of everything less than or equal to. Are you with me?
Yeah.
So here x is less than or equal to 4. This is normal. I don't change it. Yes?
Yeah.
Okay. But here x should be greater than or equal to 2.
Hmm.
Okay. Less than or equal to 4 means everything this.
Yeah.
But I don't want this part and this part because x should be greater than
Oh,
2.
okay.
So
Okay.
what will I do? I will transform this x is greater than or equal to 2 into something less than or equal to. So x greater
Yeah,
than or
makes
equal
sense.
to 2 is what? 1 minus x less than or equal to 1.
Hmm.
Yeah? So what
Yeah.
we will do? From this x less than or equal to 4, I will remove less than or equal to 1. So I will still get these three values.
Okay.
Are you okay? This should happen very quick. I'm giving you two, three examples. Tell me very, very quick how will it be? Come on.
Is that a 7 or a 9?
Whatever, 9. How will this be
Okay,
happening?
so
Okay, tell Mahad.
probability of x less than or equal to 9 minus probability of x less than or equal to 5.
Okay. Mahad, Haris, you're with me?
Yes, miss.
Okay, fine. I have this probability distribution table over here. Okay, this is x is equal to x. Can you tell me what is this?
That's x is equal to x, and this is f of x. The difference is
This is x less
this
than or equal to x.
what?
This is x less than or equal to x.
Okay, so this is the cumulative frequency, and this is the discrete frequency. If you get, if
Individual
yeah,
probability. Okay, if this was k and everything was in terms of k, so you will always start with which term? F of 6, the last term. The last term will always be 1. Can you tell me why will the last term always be 1?
because all probability equals to one.
All probability is equal to 1. Okay, now I'll pause the video and I'm giving you time. I've just removed one question from this exercise which I feel is important. Try it and then I will start again. So we are given a cumulative distribution function. Whenever it is cumulative distribution function, the thing that should come into your mind is what? Whenever it is cumulative distribution function for discrete random variable, the thing that should come into your mind is what?
X is less than or equal to x.
X is less than or equal to x. So this is for f of x, and f of x is the function is a kx square. Okay, so I will draw the cumulative frequency function. Always draw the probability distribution function or cumulative distribution function the way it is given. Now come on, tell me what will you do?
First, we're gonna write our outcomes down as small x,
Yeah, x can take these values.
which is gonna be 1, 2, 3, 4,
Okay,
and
then
then they have given us that f of x equals to kx square,
Hmm.
which means we're just gonna input our values of x into that, and we will write our outcomes, which are gonna be k, 4k, 9k, and
So
16k.
this is going to be K1 square, K2
Yes,
square, K3 square, and
and
K4
k4
square.
square.
Okay. I want to find the value of K. How would I do it?
Since we know that the cumulative frequency of all of them equals to 1, we
Hmm.
can say that 16k equals to 1.
Okay, and we find it K.
Yeah,
Okay.
and then we
X
just
is
divide from
greater
both
than
sides.
2.
Probability of x is greater than 2, so it's gonna be probability of 3 and 4 added up,
But
which is gonna be,
we don't have the distribution function. We have the cumulative function.
yeah, so what we can do is 1 minus x is less than equal to 2.
It's very important to understand greater than 2. You can visually see agar we had if we had the probability function. Okay.
Yes,
So it would be of 3 and 4. Yeah.
yes,
So it's 1 minus 2 will be included. Probability of x 1 and 2. You remove this. X is less than or equal to 2. You will remove from 1 and you will get uh, probability of x greater than 2. I hope you're with me.
yes.
Mahad,
Yeah, miss.
so this you got f of 2, right? Hello. Now we're talking about the expected value of your discrete random variable. Discrete random variable is what? Your capital X. I hope you're with me. So I'm talking about expected value E of capital X, your random variable X. It means nothing but your mean of X. Understand? Can you tell me what type of distribution is this?
This
Symmetrical.
is symmetrical
Symmetrical
distribution.
distribution. So when it is a symmetrical distribution, the expected value of X would be the middle value of X. When it is a non-symmetrical distribution, the expected value of x, what will you do? You will write your x. Your x is 0, 1, 2, 5, 10, and you have the probabilities. You will multiply both of this, you get an answer. Multiply both of this, you get an answer. So what answer you're getting is x multiplied by probability that your x is equal to x. I hope this is with me. Are you with me?
Yeah.
When you add all of this, you are going to get expected value of x. So I want you to write along with me. I would say my expected value of x is the summation of x into probability that my random variable x takes any value of x. X into this, x into this, x into this, x into this. Get an answer and add all of this. This is the formula.
Okay, so basically the formula is x into the probability,
Hmm.
and we add it all up. And e
Add
of
it all.
x square is gonna be,
Now for e of x square, please listen to me.
yeah.
I have x and p of x.
Hmm.
When I do this into this and I add all of it up, it is e of x. But I don't want e of x. Now I want e of x squared.
Yeah,
So instead of x, I have another column of x squared. Are you with me?
yeah.
You will multiply what? X square
I'm
into
gonna square. I'm gonna square x,
You will
small
have
x.
x square, remove the column of x, and you multiply the x square into this.
Yes.
So E of x square would be x square into the probability, the sum of all of it.
Yeah.
I hope you're with me.
Yes, miss.
If you saw over here, we got E of x as what? 1.5? Yes.
Yeah.
What is E of x square? Understand the square is inside the bracket.
Mean of squared values.
Means of the square value, but we've got this as 8.3.
Yes.
Okay. Now, if I want to find, can you tell me sum of the square and square of the mean? What is the meaning of Ex? It is the mean, right? Expected value of x is the mean. Can you tell
Yes.
me Ex square? Is it equal to Ex the whole square?
No.
No, miss.
No. So when I say Ex square and Ex, are these the same thing?
No, miss.
Okay. Ex is 1.5, Ex the whole square is 2.25. Can you see this?
Yeah.
And Ex square is 8.3. So these both are different. So basically you have
Yeah.
three terms. What is this?
E of x.
Mean of x, expected
Yeah.
value of x.
Expected value, mean of x.
Can you tell me, is this MS or SM?
This is ms. This is mean squared. No. Yeah, this is mean squared. This is the
This is
mean of
the
the
mean
squared values.
and this is the square value. So mean of the
Yep.
square. Okay? What is this? This is SM or MS?
This is this is SM because it's
Squared
squared mean.
mean.
Square of the mean. Okay? So this is mean of the square and this is mean square. This is mean of the square and this is mean square. It's different things. Okay? So you need to be very clear. Ex, mean of the square, square of the mean, square of the mean, and mean of the square is not the same. If using this, I will expect you to write the var formula. How will you write it? Variance. Variance would be var x. I've asked you to
I
memorize
would write it as,
Miss Salma Merchant. First thing you will write this.
you want me to give it in terms of E of x, right?
Yeah.
So I'm gonna write E of x squared. So a square is inside the bracket.
E of x square. Mean
Yeah,
of the
minus
square.
E of x the whole square.
Minus E of x the whole square. I want you to take a minute's time, pause the video, write the variance Ex square, mean of the square, square of the mean, everything together. I'll wait for you. 1 minute only. So what is E of x? E of x is the expected value of x, that is x square. Okay. Mean of the square minus square of the mean. I'm repeating again, mean of the square minus square of the mean. Mean of the square would be Ex square. Square of the mean, you take E of x and then you put the bracket and put this like that. Saying it would make it more complicated. When you write it, it becomes easier. Always use this, Miss Salma Merchant, mean of the square, square of the mean. This will help you. What is var x? Var x, I am sure you know this now. I hope you're with me.
Yes.
Okay. Now we are going to do a linear transformation. Okay. Mean and variance of a linear transformation of a random variable x. Come on, tell me, I have E of x. Whatever I'm going to find for the mean of x. I hope you're with me. Suppose this transform my variable x into a x plus b. I hope you're with me.
Yes, please repeat.
They're going to transform my variable x into a x plus b. I hope you're with me.
Yeah.
Okay, so in place of x, you are just supposed to replace a x plus b, the new code that they give to you, whatever code they give you. Okay, now you know that your mean is affected by all the operators if you're coding.
Yeah, but variance is
Yeah.
only affected by multiplication and
Okay,
division.
so in place of x, you will always take the mean. Okay, and you are finding the e of x. You have to relate this in your mind. You're finding the e of x. Then you apply your formula for coding. Mean is affected by all the operators. So it would be a e of x plus b. That means e of ax plus b is nothing but you take a, you will have the value of e of x, you multiply and plus b. I hope you are with me. I'll give you two examples. I have my e of x and the x is coded into 3x plus 4. Come on. How will you do it now? Tell me orally. X is coded, it is not actually coded, it is linear transformation. It is transformed. Okay. Now you have to find the new mean of x, the new expected value of x. Can you tell me how will you do it?
I will write e of 3x plus 4,
Which will be equal to
which will be equal to x, right?
3 e of
Oh,
x.
3e of x plus 4.
Okay. If I have e of 8x minus 9, what will this be written as?
8 e of x minus 9.
Minus 9. If I have to make it var,
So we are gonna write 3 square e of x.
3 square, what you going to write? Var x.
Yeah, var x, sorry.
Var x. And this 4 will not be affected. So variance is affected only by the operators of multiplication and division. Your mean is affected by all the operators. So the linear transformation, when your x is transformed linear ax plus b, so you they will ask you to find the expected value of your new transformation and they will ask you to find the variance of your new transformation. What you have to do, you just have to remember this would be, Mahat, can you tell me what will this be?
This one is going to be a into e of x plus b.
And for var,
Var, so we remove the plus, so it's going to be a squared into var x.
into var x. Very good.